We live in a world of chemistry. Chemicals can be used to improve the quality of life or cause great harm and catastrophic destruction. Detection of chemicals in our personal spaces, workplaces, and public areas is becoming more and more critical every day. For example, soldiers in the battlefield require protection from chemical warfare agents and toxic chemicals. People traveling across the world on public transportation systems rely on chemical detection of explosives and harmful chemicals to ensure their safety. The quality of food we eat and the beverages we drink must be free of harmful chemicals. The air we breathe needs to be clean and free of environmental contaminants that can threaten our health. It is essential that the manufacturing of electronic chips and pharmaceuticals be done in ultra-clean environments to ensure high quality and product safety. Vaporsens is developing nanofiber sensor technology for the next generation of chemical detectors. At Vaporsens and the University of Utah, a team of scientists and engineers have developed new, more sensitive, more selective chemical detectors based on nanofiber technologies. Our research and development efforts have been supported by the Utah State U-STAR program, Department of Defense, Department of Homeland Security, the National Science Foundation, and private equity investments. Let's take a closer look at the science behind the next generation chemical sensor materials. Nanofibers are the innovation behind Vaporsens' chemical detection systems. Nanofibers of different sizes and shapes are assembled from individual building block molecules. This core technology is the heart of Vaporsens' proprietary protected intellectual property. The building block molecules are placed into solution. As they experience Brownian motion in the solution, the tail groups bump into each other and stick together through van der Waals forces. Meanwhile, the core of the molecules interact through pi-pi stacking on top of each other, driving growth of the fiber on a single axis. This process is called self-assembly. Nanofibers are 1,000 times smaller than a human hair. Most nanofibers are less than 1 micron in width or diameter. The nanofibers form dense, electrically conductive networks. Vaporsens' nanofiber sensing materials are built from specifically engineered molecules that have 3 major components. The tail group determines the morphology of the fiber. The core parallene structure facilitates one-dimensional pi-pi stacking self-assembly and contributes to the electrical conductivity. The head group determines the chemical binding selectivity for the sensor. Vaporsens has developed nearly 100 different nanofibers, each providing different chemical sensing selectivity that can be customized for specific markets. Nanofibers form web-like films as they are deposited onto interdigitated electrodes, IDEs, etched onto the surface of a microchip. A bias voltage is applied through the nanofiber network. As target chemicals interact with the nanofibers, they can either donate or withdraw an electron. This generates an increase or decrease in the current, which is registered as a signal. The wide range of nanofibers allows us to fabricate microsensor arrays for different applications. A single detector can be used in a variety of applications, simply by changing the sensor card and loading the appropriate library. Each nanofiber material responds differently to different chemicals. An array of 16 or more different nanofibers give unique response patterns to each chemical. These unique responses are interpreted into chemical fingerprints through our proprietary algorithms, enabling identification of a specific chemical or class of chemicals. A simple user interface alerts the presence of a target chemical. Early prototype devices have been developed to detect drugs and explosives. Future commercial products will be smaller, lighter, handheld, and wearable detectors. Our sensors are useful for detecting explosives, chemical warfare agents, hazardous materials, toxic industrial chemicals, adverse chemicals in consumer products, and other volatile organic compounds that are environmental pollutants. Advantages of nanofiber-based sensing technology include durability, high selectivity, yielding low false positive rates, excellent sensitivity, resulting in low false negative rates, cost-effective, rapid response times, low power consumption, no calibration required, small size, lightweight, application specific. Vaporsense's nanofiber technology is defining the next generation of chemical sensors. Explore our website for additional information. We invite you to discover how these new chemical sensors can make a difference for your applications.